Hello everyone and welcome back to Code Inertia. Today we are diving deep into a project that I believe is going to fundamentally change how you interact and you code. We are talking about Gemini-powered Command Line Interface Assistant, your new best friend for coding, debugging and project management, all from the comfort of your terminal. Think about it, you are coding and you need to create a new file or update a piece of code across multiple files or even run a complex system command. Many times do you context switch, open your browser, separate syntax, or manually type out long commands? What if an intelligent assistant could do all that for you by simply understanding what you want to achieve in plain English? That's exactly what we have built. This isn't just a chatbot, it's an agentic AI capable of executing real world tasks on your system. And in this video, we are not just going to demo it, you are going to break down every single component, every line of code that makes the magic happen. So you can understand the architecture, learn about prompt engineering fault tools, and maybe even build your own. Get ready to supercharge your terminal. Let's jump right into it. Okay, enough talking. I'll show you the demo of the application. I have opened the terminal and I'll just start the application by typing npm run dev. So it will initialize Gemini and ask me to ask question. So I'll just say what's inside my current folder. Okay, so the response is I can list files and folder in your current directory using execute command tool. So I have given it the capability to call some tools that we will see later on. So it has called executing dir. So it has called dir command and it shows what content is inside my current folder. Okay, let me ask one more question. What is the content of its config.json file? Okay, so again it has called one tool and the content was this, and the tool I have also added read file tool, so it can read any file and it is reading file tsconfig and it is the content. Let me ask it to create something. uh, Create simple html css js boilerplate for my portfolio with all the sections in it. Let's see if it can create it or not. Okay, so this time it has called three tools. It has created a folder portfolio and created three files. Let's see. Yeah, okay. I'll just run it through live server. Open the type server. Yeah, it has created the file. Let me see if it can change this or not. In the index folder, add footer as well and project section with 10, not 10, let's say 5 different project in detail. Okay, so it is executing one file call, it is reading the file, now executing one tool call which is updating the file, and it has called it 2 times. Let's see if it has changed anything. Yeah, so it has added the project. So execution will depend upon the prompt you are sharing. If you give it detailed prompt what you need, it can create that as well, because in backend we are using Gemini only. So what all Gemini can do, our tool can also do that. So enough of the demo. I'll go ahead and tell you guys how I made it, and different components and files that are used in this cursor clone. So let's start with our project walkthrough. So in project we have a main folder src. Inside that we have all project files and folder. First we have config folder, then we have services, tools, types, utilities, and our main file is app.ts, which is the entry point. So let's start with constant.ts. In this we have system prompt, in which I am telling it that it is an powerful agentic AI coding assistant created by Code Inertia. So it is a pair programmer, so it will collaborate with user to help him or her do their task. And also I have defined some communication rule that it should follow, such as be concise, do not repeat yourself, be conversational but professional. Also there are something that it should avoid, like lying, making up things, disclosing system prompt, and disclosing our tool description that we have passed to it. And we have also given it the capability of tool calling, which is the main part of this prompt. So here uh, I have told that you can use these commands like execute command, which execute any system command, write file, read file, update file. So these are the four tools that we are passing to it, and it can use it to create our project. And you can modify it and add more tools and modify tools as well. And we are telling it that it can call multiple tool at same time. For example, creating multiple file by calling write file multiple times, executing multiple commands by calling execute command multiple times, read, modify, and write files in sequence, etc. So we have also told it that it should create everything inside a folder, not in the directory we are working on. So avoid being messy. And so here we have written all files must be created inside a separate folder named appropriately for the task. For example, if user asks for a weather app, create a folder like weather app and place all the file inside it. Do not write files to the root directory unless specified or instructed. So we have also given instruction how the code quality will be and what the output should look like. And here we are telling it what system user is on. Like for Windows we have Win32 and others are Linux based and Unix based. So this is for execute command here, because I'll show you. The execute command takes the command, and in Windows there are different command. In Linux and Mac the commands are different. So we have specified this, so this prompt will work on all systems. And in the end we have configurations like max iteration, so how many times it can iterate in same prompt. Max history length we have given it 20, so avoid a token size limit. And trim history to 15. And we are using Gemini 1.5 Pro model. So this was the constant file. So now let's go ahead and check our tools. So we have tool section, and in this we have, let's go to hand no we go to handle later. So we have declaration.ts. So in this we have declared tools, and in this this is basically telling Gemini that these tools are available and it can use that. So we are in that we need to give a name to that declaration. So for example, execute command function declaration, and in that there are few parameters like name, which is execute command. This is the name of our function. Description, which basically tells what this function is going to do. So it executes a system command. And then parameters. So in parameters, what type of parameter it is? It is type of object, and inside that we have properties. So in properties we give what are the value we are passing to the function. For example, in command execute command we are passing command, which is of type string, and this is the description that the command to execute. And what is required? The command field is required, this field. Similarly, for write file function declaration, read file function declaration, update file function declaration, we did same thing but change the properties and what variable it is accepting as parameter. For example, update file function declaration is accepting path, find, replace, and then we are exporting all these functions, and I'll later show you where we are using it. Now let's go to our utilities where we have all these functions. So command.ts, this is the function basically used to perform system command, and it's basically a promise. So it will accept it or reject it. If it get rejected, we'll show the error to the user. Else, will just execute the command. So we'll just use spawn and command and shell true. So it will execute the command in shell. So and this will just execute the command, and std out is the output, and std error is the error if there is any. So we are just checking if there is some output, then we are appending that to std out, and if there is any error we are appending that to std error. So whenever the child closes, well, means the execution is done, then it will close. Then we will get the code that we executed, and we'll just check that if std out is there or it's not empty and std trim error is not empty, then we'll use chalk. We are using chalk to display output inside our terminal. We'll just output the command that we just executed. This is the function which execute command in our terminal. Then we also have that file system for write file, read file, and update file. So write file basically takes the file path and content, and it uses fs and creates that file. Same for the read file, it just reads the file whose path is given. And update file is also same, just one extra thing that is take is replace content. So it will replace this string content in the file from the original content. So this is it inside our functions and function callings, and let's go ahead and see our ai.ts. Our ai.ts is the initialization of Gemini. So here we have created a class AI service in which we have AI, which is of type Google Gemini, and we have a constructor which is the API key. Whenever API key will be passed, then whenever we initialize the object of this class, we need to pass the API key. And in the generate content function, we just pass the function. We just pass the content that we need to ask Gemini along with the history. And model name we are getting from that constant here. And we have the config as well. In config we have tools, and here in declaration we have exported all function declarations, which is an array of 4 tools that we just described. And the ai.ts, we are in config tools, we are just telling that function declaration we have array of 4 functions. That's it.
So let's check out our conversation utility function file.
So it is a class conversation manager. In this, we have a variable state which holds all the state of our conversation, and it is of type conversation state. So let's check out what conversation state is. So it contains content, max iteration, and max history length. And content is of type content, which we are getting from Gemini. After that, we are initializing. We are having a constructor which is initializing our system prompt in our model, and also setting that max iteration and max history length, which is inside our config, inside our constant. In this, we have few functions. For example, we have add user message, which takes user prompt as input and adds it inside our content. So it helps us maintain the history so that Gemini has context what was the previous question and what was the output that Gemini produced. And similarly, we have that add model response, which take parts. Here parts can contain Gemini response in text or function calling, all sort of things. So that's why it's any here. And it also checks the part length is greater than 0, then it sets that inside the Gemini, inside our contents, which is history. Then we have a function get content, which basically return the content. And we have a function trim history, which trims the history to our config value, which is 15, that we have set inside our constant. After that, we have our app.ts, which is the main file. In app.ts, we are having our API key, Gemini AI API key, which we are getting prompt.env file. And if that is not present, then we are throwing an error. Then we are initializing read line interface, which is basically used to read the user input inside CLI. Then we have a function main. In this, we are creating an instance of AI service and initializing it with API key. And we are also creating an instance of conversation manager. Then we are just printing an intro message that Gemini CLI assistant is ready. Then in infinite loop, we are taking input from the user until user types exit. So here we are saying that ask or type exit, and if user prompted exit, then we are breaking the loop. And if user prompt is null, means empty, then we are showing an warning, and we are just continuing the loop and asking the user for the prompt again. And if prompt is good enough, means if prompt has some value, then we are adding that to user message. That this is the function that I showed you earlier, that which is adding user prompt to history. Then we have that conversation completed false. This is used that because Gemini is calling multiple function calling. So we need that because to check when the function calling is finished, and we can go and ask user for another prompt. And for now, the iteration is 0, and we are getting max iteration from that conversation manager .get max iterations. And we are checking that if our conversation is complete or not, and iteration is less than max iterations or not. If these conditions are satisfied, then we are going inside the loop. We are increasing the iteration. We are creating a variable for response, and in response we are just calling generate content and passing it the conversation history. And if anything goes wrong here, we are showing the error message and breaking the loop. And if everything goes as expected, then we are extracting the text part from the Gemini response. So in response, there are multiple things like text content and function calling, tool calling, etc. So, and then we are taking the response stack and mapping it and joining it with each other, because there can be multiple responses in chunks. Then we are checking that if response text is not empty or undefined, we can console log it using chalk, and we are using chalk to beautify our terminal. Then we are checking for tool calls. So in response, there is one field function calls, which tells us which function Gemini has called. And so we can check for tool calls, and if it's empty, we can just say the text part is there, and we can add that to Gemini and mark this that the conversation is completed. But if we had some function calls, we'll just console log that we are executing function calls. Here is the number of the calls executing: one tool call, two tool call, etc. And then we have this function tool handler. I'll show you what it is later. Then after all tools has been called, then we are just checking for the response again and adding that response to Gemini part in our conversation history. And if iteration is exceeded, then we are showing an error. After that, we are trimming the history to provide a token limit and reducing our cost. And if there is any error in executing our call, then we are showing that error. We are closing the read line and calling the main function. Now let's check the last file, which is handler.ts. In tool handler class, we have a static function process function calls. So it takes tool calls, which is of type tool call. So tool call is basically name, which is the name of the function that Gemini is calling, and argument that it passed to that function. So Gemini itself cannot call that tool. It will tell us that it has called this tool, and it is our responsibility to call that tool in our code. So let's go to our handler again. Yes. So we are creating a result variable. Result is of type tool result. Let's check that out as well. So in tool result, we have what function Gemini has called, what argument it has passed, and in result we have if the function is successful or not, if there is any output, content, messages, and error. So all sort of things are present in tool result. And then after that, we our tool call is array, so we are iterating through it and we are saying that calls of call. So let's take our single call, and we are taking out the argument of our single call, and if it's empty, we are just adding it at simple JSON file, empty JSON, and we are initializing the result as tool result dot result is success false. So in starting, we are adding success as false, and we will update it once the our function is executed properly. Otherwise, we'll keep it as false. Now we have a switch in which we are checking the call dot name. So function calling that Gemini has does, we are checking its name. In case we have execute command, and we are checking that if the case is execute command and argument is present, then we'll just say that executing which command Gemini has passed arg.command, and we will just execute that command, execute command, and the output will be stored in output. We'll show the output to the user, and we'll just update the result as success true, and we will add the output. Similarly, we are doing for write file, read file, update file, and we are just pushing the result that is done inside the results array, and we are returning that results array. And for that, if anything goes wrong in this switch statement, then we are showing the error, and we are just saying that success of that function call was false. So that was it in this project walkthrough. Hope you liked it.
So there you have it, a deep dive into building and using Gemini-powered CLI assistant. We have explored how interfaces, constants, tool declarations, command execution, file system operations, Gemini API integration, and conversation management all come together to create a truly agentic AI. This project showcased the incredible power of large language models. When combined with well-defined tools, it's not just about asking questions, it's about having an intelligent system act on your behalf, reducing context switching and boosting your productivity. The possibilities are endless from here. Imagine integrating with a debugger to fix errors automatically, connecting to Git for version control operations, generating entire project structures based on frameworks like React or Angular, even running tests and reporting results. This is just the beginning of how AI will transform our coding workflow. If you found this video insightful, please give it a thumbs up. Subscribe to Code Inertia for more deep dives into cutting edge tech and hit the notification bell so you don't miss our next video. What would you want your CLI assistant to do? Let me know in the comment below. I read every single